Okay, so we're going to take a look at what's called the difference quotient. So the difference quotient is just a fancy way of writing the slope. Now you may ask, why do we have to write the slope a different way than we've already learned it? And the answer is because we're using the slope in a different context. And so let's take a look here. So at the top in red, we have the traditional way that we have derived slope. We've got, the slope of some line here. We make it into a right triangle. The vertical distance is y2 minus y1. The horizontal distance is x2 minus x1. And when we take the ratio of those distances, we get the slope. And that's an excellent way for calculating the slope when you're calculating the slope from 2 points. So in algebra, that served us perfectly fine. When you start getting along to, advanced algebra and calculus, you want to calculate the slope from a function. So in this context of calculating the slope from a function, it is helpful to write things a little bit differently. So you can see all we have down here, it's in the blue, is the same exact information that we have up here in the red, but we have written it from a different perspective. So in calculus, a lot of times instead of writing y values, we like to do things in terms of functions. So we talk about it as being a function value. Instead of the y value, we will write f of x. So notice that the y values up here in red, below in blue, are all written as function values, f of x. Instead of y, it's f of x. So our y1 is f of x. The other thing we like to do here, instead of having an x1 and an x2, we want to base everything on a single x. So what we do is we take x and then we move h distance away from x. So here we have x, and then we move h units horizontally, and that puts us at x plus h. If you start at x and you move h units, you're now at x plus h, which would make the y value corresponding to x plus h f of x plus h. Okay? So that makes that the distance we covered horizontally is h. So what we used to call x2 minus x1 is now h. And what we used to call y2 minus y1 is now f of x plus h, the y value up here, minus f of x, the y value down here. So these two formulas for slope are really giving us the same exact information, but one is doing it with point coordinates and one is doing it with functional values. So in calculus, a lot of calculus these days is taught from the perspective of functional notation, and so you'll see this form of slope used much more in calculus, and a lot of algebra is taught from a point perspective, so you see this version of slope in algebra. But as you can see from the picture, they're representing the same exact thing. Okay, so that's great for understanding the difference quotient. How do we calculate the difference quotient? So let's take a look. Okay, so here we have a function that I've just randomly picked, x squared minus 3x plus 4, and we want to calculate the difference quotient. So there's that part of the difference quotient which sometimes can get a little bit messy. It's the f of x plus h part. That's like kind of the hardest part to calculate in the whole thing. So I like to do that kind of first or off to the side. So it's not, the calculations aren't in there muddying up the actual work that I'm trying to do. So we take f of x plus h. So f of x plus h means that we're going to take our original function, and wherever there's an x, we're going to substitute in an x plus h. So that becomes x plus h squared minus 3 times x plus h plus 4. Now, remember when we square x plus h, that does not become x squared plus h squared, right? You have to FOIL it out. It's x plus h times x plus h. You FOIL it out, and what you're going to get is you're going to get x squared plus 2xh. That's your outer and inner term of your FOIL. And then plus h squared, which would be the L part. So this here, x squared plus 2xh plus h squared, is just this when you FOIL it out, okay? Now over here, we're going to distribute the minus 3 into the x plus h, giving us negative 3x minus 3h. And then, of course, the plus 4 just becomes plus 4. So now we want to take the next step. Let's see what we're going to do now. Now we're going to start plugging everything into our actual difference quotient. So I always like to start by writing the difference quotient. Anytime you write a formula, your formula is kind of your roadmap through the problem. So it kind of makes sense. Put your roadmap on the paper so that you can take a look at it trying to remember formulas while you're substituting into them is a good way to make mistakes. So a good idea to just write that formula down and then plug stuff in. So you can see this first set of parentheses, that's just the f of x plus h that we calculated up here, right? The x squared plus 2xh plus h squared minus 3x minus 3h plus 4. That's what this parentheses is. And then we have the minus f of x. So we've got this is the f of x part. We just go up and look at our original function, and then we put it in here. Now notice that I put it in parentheses because if I'm not careful, I won't distribute this negative in correctly, and then our terms are not going to cancel, and our problem won't come out right. So make sure that when you're putting in the f of x, throw some parentheses around it so that you remember to distribute the negative into the f of x pieces. Okay? Then we have this plus h at the bottom that we've been looking at. Now, what we're going to do is just basically distribute the h in and get rid of some of these parentheses. That way we can start combining terms. So that's all I've done here. Notice that the signs are different on these last three terms because I distributed the negative in. So we can see that being distributed, and the first part didn't change. Okay, but now, see, this is the part where it starts to get a little overwhelming in the difference quotient. And you're like, man, there's so much going on here. But this is where the nice part happens and canceling starts to occur. Every term from your f of x, this piece on the back end, that's now negative x squared plus 3x minus 4, each of those three terms should cancel with a term previously in the problem. So see how we have a negative x squared and a plus x squared? Cancel those out. We have a plus 3x and a minus 3x, cancel those out. A plus 4 and a minus 4, cancel those out. And when you do, that fraction's going to get a whole lot cleaner for us. Right here, it simplifies down to this little tiny fraction right here. Look how small that thing got. Now we're going to divide the top and bottom by h. Be careful. I see a lot of people make the mistake of crossing this h out and this h in the back. That's not how canceling works. It's not just wishful thinking of crossing things out that you don't want to be there. Canceling is really dividing. We are dividing the top of the fraction by h. We are dividing the bottom of the fraction by h. Well, if you divide the top of the fraction by h, you have to take it out from everything. So everything loses an h. Okay? Doing that, the whole problem becomes 2x plus h minus 3, and that is your simplified difference quotient. That's all we do with it for now. In calculus, this is step one of a bigger problem. Now you're gonna start doing more calculus stuff in there. But for now, this is all we're doing. We're getting you ready for that problem in calculus where you're going to take the limit of the difference quotient, which of course doesn't make sense yet because we don't know what a limit is. But right now, we just want to be able to calculate this reliably. And those of you who are going on to calculus, just learn this now, and you're going to get a whole lot more points when you're in calculus and you're already comfortable with the difference quotient.